if our galaxy has billions of habitable planets? Why is the cosmic radio sky completely, hauntingly silent? In 1950, a group of scientists discussed reports of unidentified flying objects. Their conversation soon shifted to a simple, logical calculation of our galaxy's scale. The Milky Way contains hundreds of billions of stars, much older than our Sun. Statistically, even if a tiny fraction developed life, thousands of civilizations should exist. Given millions of years, advanced species could easily colonize the entire galaxy using probes. Yet, when we scan the night sky, we find absolute, quiet nothingness. This fundamental contradiction between high probability and zero evidence is the Fermi Paradox. For decades, astronomers and astrophysicists have struggled to resolve this deep cosmic mystery. Why has not a single verifiably artificial signal ever crossed our sensors? Recent breakthroughs in technological models and physics offer a groundbreaking new answer. Have we finally discovered the real reason behind this great silence? Today, we examine the newest, most compelling scientific solutions to this ultimate question. One of the classic solutions proposed is known as the Great Filter Hypothesis. This theory suggests a massive evolutionary wall exists somewhere on the path to space. It is a barrier so difficult that almost no species can pass through it. The crucial question for humanity is, where is this great filter located? Is this filter behind us, meaning the emergence of complex life is extremely rare? If so, Earth is an incredibly lucky oasis, and we are truly alone. But what if the Great Filter actually lies ahead of our current timeline? This implies that civilizations inevitably collapse before reaching their true interstellar capability. Environmental degradation, technological self-destruction, or resource exhaustion could be universal hurdles. Under this model, the galaxy is empty because advanced life destroys itself very quickly. The vast silence of space becomes a tragic cosmic graveyard of failed worlds. But other scientists suggest a completely different perspective on this universal quiet. What if advanced civilizations simply choose not to explore physical space? We traditionally assume technological species will constantly expand outward like biological pioneers. But our own technological trajectory suggests that progress might shift inward. Once a civilization develops advanced artificial intelligence, physical expansion becomes highly inefficient. Why spend thousands of years traveling cold space when you can build virtual realities? An advanced species might transition their entire consciousness into synthetic, computing substrates. They would create hyper-efficient digital realms, requiring far less physical space and energy. Physical space travel requires astronomical amounts of fuel, materials, and long-term planning. Digital civilizations would minimize their physical footprint, becoming virtually invisible to us. They would emit no high-power radio leakage into the outer universe. Instead, their communication networks would utilize tightly directed, private quantum channels. Under this intriguing model, civilizations do not go extinct. They just step inward. They leave the physical stage to inhabit infinite, beautifully designed digital realms. Another mathematical model resolving the paradox is called the percolation theory. In classic models, astronomers assumed colonizing species would spread uniformly across space. However, physical systems rarely expand in perfect, predictable geometric circles.
Star systems are in constant orbital motion relative to one another over time.
This orbital drift makes interstellar travel distances fluctuate wildly over millions of years.
A species will naturally colonize close, resource-rich stars while ignoring distant ones.
This selective expansion creates a complex, patchy percolation pattern across the galaxy.
We see pockets of developed interstellar clusters, surrounded by vast, untouched wilderness.
Earth may simply reside in a low-density, unvisited sector of the galaxy. Alternatively, the famous zoo hypothesis suggests advanced civilizations know we are here. Under this model, they deliberately avoid contact to let human culture develop naturally.
They protect us from technological contamination, observing us from a quiet distance.
They might use disguised, stealth quantum sensors stationed across our solar system. We may reside inside a cosmic nature reserve without ever realizing we are watched. A completely different observational breakthrough suggests our search methods are fundamentally flawed. For decades, search programs have listened for high-power radio broadcasts leaking from space. But looking at Earth's history, our own radio broadcasting era was extremely short.
Our loudest radio transmission era lasted less than a single century overall. As our technology matured, we shifted away from noisy analog towers to optics. We now use directional lasers, fiber optics, and low-power digital signals daily.
Today, Earth leaks vastly less radio noise into deep space than before. If a civilization's noisy radio window lasts only a century, detecting it is rare.
To pick up a signal, our telescopes must point at the perfect target. We must listen at the exact right 100-year window of their development. The probability of two technological species overlapping in time is astronomically low.
Space is not silent because nobody is there. We use obsolete frequencies.
Resolving the Fermi Paradox forces humanity to confront its place in the cosmos. Whether the great filter is behind us, or civilizations transition to virtual realms. The silence of the universe is not a failure, but a teacher. It highlights how rare, fragile, and valuable our technological civilization truly is. As next-generation telescopes search for biosignatures, we draw closer to the truth.
Every silent star system reminds us to cherish and protect our pale blue dot.
Which Fermi Paradox solution do you believe is the most likely outcome? Share your thoughts and theories in the comments section below. If you enjoyed exploring the deepest questions of existence, hit the like button. Subscribe and ring the notification bell for new space science videos every week.
Thank you for watching, and keep searching for answers in the stars.
The quest to solve this mystery will continue to inspire generations of explorers. Each new space telescope we launch brings us closer to finding a neighbor. Even if we only find microscopic life, it will change history forever. Underground oceans in our own solar system might hold the key. Scientists are analyzing exoplanet light data every day for biological markers. To pick up a signal, our telescopes must point at the perfect target.
Until that moment, we will keep looking up with hope and curiosity. The silence is not an empty void, but a canvas for discovery. Underground oceans in our own solar system might hold the key. Our journey has only just begun in this vast and silent cosmos. Thank you for joining us on this incredible voyage of the mind. Remember to leave your thoughts in the comments and stay curious.
Until next time, keep your eyes on the beautiful stars.